All right, so we are going to look at the right triangle word problems section, which is day 3 of Unit 8, right triangle trigonometry. We're going to do a couple examples together, and then you'll have some time to work on your own. So, um, in right triangle word problems, the first thing that you need to do is decide whether to use trig or the Pythagorean theorem. If you're using trig, that means that you're trying to find sides or angles. If you're only dealing with sides, then you're going to use the Pythagorean theorem. So once you decide what you're going to use, you want to label the sides and draw a picture if it's not given, and then keep your answers exact until the final step if possible to avoid any rounding mistakes. And then you're going to finish solving, obviously. So a couple helpful things. In daily life, you can use trig. I know that you probably won't ever, but you could if you needed to find angle of elevation. So angle of elevation is going from the ground and the angle looking up at something. Angle of depression is like if you were standing on top of a building and you would be looking down at something on the ground. So elevation is the angle going up, depression is the angle going down. And then your directions, north, east, south, and west, are also really important. So the first question we're going to go through. A wooden beam 24 feet long leans against a wall and makes an angle of 71 degrees with the ground. How high up the wall does the beam reach to the nearest foot? Well, I can see here that I'm dealing with 24 feet, which is going to be a side, and 71 degrees, which is an angle. So I'm going to use trig, but let's draw a picture just to make sure. So we have our house and the ground, and we have a wooden beam leaning against it. And we know that the beam is 24 feet long, and we know that it makes a 71 degree angle. So from here, we want to find how far up the wall does it go. So this piece right here. So if we label our hypotenuse, opposite, and adjacent, we can see that we are using opposite and hypotenuse, so sine. And the angle we're dealing with is 71 degrees. So sine equals opposite over hypotenuse, so x over 24. We'll do our cross multiplication here and say that x equals 24 sine of 71 degrees. And when you put that in your calculator, you'll end up with, to the nearest foot, 23 feet. So this board is leaned against here, and it goes 23 feet up that wall. The second one we're going to do is number 2 here. It says the hypotenuse of a right triangle is 3 more than twice one of the legs. The second leg is 2 more than twice the first leg. What's the length of the longer leg of the triangle? Well, we're dealing with the hypotenuse, the legs, and the second leg. So most likely we're going to use the Pythagorean theorem. But again, let's draw a picture just to make sure. So we have our right triangle, and it says that the hypotenuse is 3 more than twice one of the legs. I'm going to use L. So we'll pick L over here. The second leg is 2 more than twice the first leg. So we have all 3 sides. We can plug this into the Pythagorean theorem. So we'll have L squared plus 2L plus 2 squared equals 2L plus 3 squared. And now this is going to involve a lot of foiling and a lot of combining like terms. So why don't you pause the video and see if you can finish this one up and resume it in just a second. Okay, so when you FOIL this out, you'll end up with L squared plus 4L squared plus 8L plus 4 equals 4L squared plus 12L plus 9. If we get everything on one side, so that it's equal to 0, we'll end up with L squared minus 4L minus 5 equals 0. We can then factor that. If you prefer to use the quadratic formula, you can do that also. We'll have x minus 5 and x plus 1. So x is 5 or x is negative 1. I'm sorry, I switched to x's there. These are L's. This negative 1 will result in a side length that is negative, so we reject it. And our leg is 5. But the question asks, what is the longer leg of the triangle? So we need to go back and plug that in. So 2 times 5 plus 2 will give us 12 for our longer leg, which is our answer. We're going to skip number 3 and jump down to number 4 here, which says a 20-foot pole leaning against a wall reaches a point 18 feet above the ground. What is the angle that the pole makes with the ground to the nearest tenth of a degree? So again, we have this is a popular problem where you have a pole or a piece of wood leaning against a wall, and it reaches a point 18 feet up, and the pole is 20 feet long. So what is the angle, I'm going to use theta, that it makes to the nearest tenth of a degree? Well, again, we can label our hypotenuse, our opposite, and our adjacent. And then we can see that opposite and hypotenuse are used again, meaning that sine will be the appropriate trig ratio. So I'm going to put sine of theta equals opposite over hypotenuse, which is 18 over 20. And now I need to get rid of that sine. So to do that, I'm going to use sine inverse, or sine negative 1. Sine negative 1 of both sides. And I'll be left with theta equals, when I put into my calculator sine negative 1 of 18 over 20, I will end up with about 64.2 degrees as my angle measure. So that's saying that the pole creates an angle of 64.2 degrees with the ground. I know I went through those a little quickly, so if you need to rewind and rewatch something, that's absolutely fine. There are a bunch more problems here that you can try, and we will go through the answers in class if you have questions. Other than that, I hope you have a spectacular day. Your homework tonight will be the worksheet that you got in your folder, the Unit 8 Homework 3, and I will talk to you later.